Alright, so this is test review for Chapter 4, which is actually your Benchmark 5 test. Looking at this sheet here where it says number 10, the figure below shows the graph of f prime, the derivative of the function f, for x is between negative 8 and 8. The graph has horizontal tangent lines at x equal negative 7. So at negative 7 is a horizontal tangent line right there, meaning a slope of 0. Also at x equal negative 5, so right at negative 5 there's a slope of 0. At x equal 1, slope of 0, horizontal tangent line. And it has a vertical tangent at x equal negative 3. So if it's a vertical tangent at negative 3, what's the derivative at negative 3? Undefined. Undefined, good. Okay. Part A. Find all values of x, where x is between negative 8 and 8. Notice we're not including the endpoints. At which f attains a relative minimum. Justify your answer. Find all values of x between negative 8 and 8, not including the endpoints, at which f attains a relative maximum. Justify your answer. So let's do that first. The way I'm going to do that is make a number line chart. We may not need to make a number line chart, but I think for a lot of people it's helpful. And this is my derivative. Top number is going to be my derivative of f prime. Bottom number is going to represent x. Notice it tells you that the y-coordinate represents your derivative. So we're going to be looking at the y-coordinates. We're not going to look at the slope of the graph. We're going to look at the y-coordinates to determine the derivative. So from negative 8 to negative 3, what do you notice about all these y-coordinates here? I have to go left and I have to go up to get to them. So what's that tell you about the y-coordinate? Positive. They're positive. Yeah, they're above the x-axis. It's got a positive y-coordinate, meaning it's got a positive derivative. How about at negative 3? What's the y-coordinate at negative 3? 0. That's the point, negative 3, 0. So the y-coordinate is 0, which means f prime is 0, because y-coordinate equals the derivative. How about from negative 3 to 5? What's the y-coordinate? Negative. So that means the derivative of f is negative between negative 3 and 5.
Did we say that negative 3 was undefined?
So the slope is undefined. Good question. I'm glad you brought that up. The slope's undefined, but the y-coordinate is 0. Okay? We're not looking at the slope right now. That's the biggest mistake people make, is they look at the slope when they should be looking at the y-coordinate. Here's your clue. It tells you the y-coordinate equals the derivative. How about at 5? What's the y-coordinate? 0. Good. How about between 5 and 8? Positive. We don't have to worry about at negative 8 or at 8, because our directions here say that x has to be between negative 8 and 8. So that's going to help me sketch the original graph. That's going to tell me that between negative 8 and negative 3, the graph of f of x, let's make a sketch of f of x. What's the f of x graph going to be doing between negative 8 and negative 3? Going up, increasing. Okay? So it's going to increase, something like this. It's going to increase. And it's going to reach a slope of 0, because the derivative is 0 here. Then what's the graph going to do? Decrease. And then what's it going to do? Increase. Great. So it's going to increase until negative 3, and then decrease until negative 5, and then increase again. So now we can answer our questions. Where does the graph of f, which is the sketch down below, reach a relative minimum?
5.
Negative 5, right, because that's where the graph switches from, actually that should be positive 5, yeah, I'm sorry about that. That's where the graph switches from decreasing to increasing. So the answer is x equal 5. Justification, because f prime of x switches from negative to positive. Right? We're switching from a negative derivative, decreasing function, to a positive derivative, which means an increasing function. You have to make sure you have this justification too. Part B. Find all values of x between negative 8 and 8 at which f attains a relative maximum. What would be the answer for that question? Negative 3. Yep, right here's a relative maximum. X equals negative 3 because, what would be my justification? Right, and don't say it, say f prime. I know what you mean, but on the test, I really want you to be specific. When you say it, I don't know if you mean slope, or if you mean f, or you mean f prime, or f double prime. Be specific and say the derivative of f of x, or f prime of x, switches from positive to negative. And when f prime of x switches from positive to negative, that means the original function f of x is switching from increasing to decreasing, so you have a maximum. It's kind of a dirty word in calculus. You don't want to use it because you want to be specific. And it is pronoun, it's not very specific. You want to make sure you say exactly what you mean. Okay. Any questions about parts A to B? All right, part C. Find all values for x between negative 8 and 8 at which f double prime of x is greater than 0. So this chart, f prime of x, is not going to help us with f double prime. So I'm going to erase this. And I think you all know that f double prime equals the derivative of f prime of x. Right? If you use the derivative of f prime, you get f double prime. What's another word we could use for derivative, though? Slope. F double prime is the slope of f prime. So if we just look at the slope of our f prime graph, that'll tell us f double prime. So I'm going to make another number line chart. This time, it's going to represent f double prime. So between negative 8 and negative 7, what's the slope? Negative. How about at negative 7, what's the slope? 0. Between negative 7 and negative 5, what's the slope? Positive. I'm talking about the slope of f prime, so really I'm talking about f double prime. At 5, what's the slope? 0. How about at negative 3, what's the slope? Undefined, because it's a vertical tangent right there. It told us that in the directions. And we have negative slope from negative 3 all the way to 1. At 1, the slope is 0. From 1 to 5, actually from 1 to 8, the slope is positive. So I'm looking at the slope of the first derivative to get the second derivative. So this isn't really asking the question, but I want to go over this. If it's got a negative second derivative, what does that tell us about the original function f? Concave down. So this is telling me the original graph is going concave down, concave up, concave down, concave down, concave up. Okay? For our question, just ask, where is f double prime of x greater than 0? So what would be the first interval where that happens? Negative 7 to negative 5, good. So between negative 7 and negative 5, we have a positive second derivative, which is greater than 0. And then where else? Between 1 and 8, good. We'll use a union symbol to show that both of these are correct answers. Why am I not including the endpoints? What's the second derivative at the endpoint here? 0, right? And this is greater than 0. So that's the reason we're using curved brackets to not include the endpoints. Justification would be something like this. The slope of the f prime of x graph is positive on these intervals. It wouldn't hurt to show this too on the paper. F double prime of x equals the slope of f prime of x. Any questions about this problem?